Hello.
Hello.
Okay, so how are you? Can you hear me properly?
Yeah. Yes, I hear you. Thank you. I'm fine.
Okay.
And how are you?
Okay, so I am fine. Thank you. Okay. Okay, so basically today is our last day of the seventh number of online training program. So basically today I will try to discuss about the rest of the part which is not completed, such as how you can easily calculate the big area, calculated the big area land use land cover classified area. How you can easily calculate it for the big region, and then how you can easily add the different types of indices in your land use land cover classification. We also try to discuss about this part, and also try to show you this part how you can easily make the change detection for the different time period. Suppose you want to make the map for 1991 and 2021. Now you want to make the change detection between the two time period land use land cover classification map, and also try to identify the change area. Okay, so let's go over to this class. I also just share my screen, then try to show you the all of the things step by step. I just simply start the recording session first. Okay, so now can you see my screen?
Yes,
Okay.
I have seen.
Okay, so basically, first of all, I will try to show you this part. How you can easily calculate the big region land use land cover classified area. Okay, and previous class we also try to show you this part how you can easily make the small region, such as suppose a small city or a small area, how you can easily calculate the area using the chart. Okay, first of all, you can make the chart, and from the chart we can easily calculate the area. Okay, but when you want to apply this method, such as big region, such as whole country boundary of Ukraine or whole country boundary of India, whole country boundary of Bangladesh, so any big region, then the chart is not work. Then we need to apply the another method and then try to calculate the area. So today I also try to show you this part. So basically in this time you can see here I already added the classified land use land cover classified map for the Ukraine, and we can classify all of the classes. So we classified all of the classes such as tree cover, shrubland, grassland, cropland, field of area, bare land, snow and ice, permanent water bodies, herbaceous wetland, mangrove, moss and lichen. So here we can classify total all of the classes we can classify, and this data set provide you, basically you can see this data set provide you the European Space Agency world cover data. It resolution is the 10 meter, very high resolution image. We can get 10-meter resolution in here, and land cover map and 10-meter resolution based on the Sentinel-1 and Sentinel-2 data set. The data set
Radar.
yeah.
It together radar and optic.
Yeah, optic. Yeah, and we
If
can get the
only
yeah. So it's the combination of the
Sentinel.
Sentinel-1 and Sentinel-2, two satellite images combination, and get the training point. Yeah. And the world cover product come with the total 11 number land cover classes. Okay, and we can get the dataset between this time period. Recently this dataset you can see we can get the dataset year of 2020 to 2020-21. Between this time
only for 1 year.
Yeah, only for the 1 year. Yeah. And future it also updating this data set. Then we can also get the other year future. Then we can use the land use land cover data set as the data set. So in this time I just use this data set, and then I just make the map for this region of Ukraine. So first of all, I just simply import the Ukraine boundary shape file. So this is the Ukraine boundary shape file because I want to work with this data set for the whole country boundary of Ukraine. So I simply import this Ukraine boundary in here. You can see.
Yes.
And then I just simply imported the data set. This is my data set. This data set. And in this time here you can see I use here the first Okay, so basically, before the using the first, I just simply try to add here the print function and check how many images I want to get when I want to use at the first. So I just simply print this. So just I simply use at the print and then simply call the data set and use at the size function and click the run. Okay. Is showing this type of, like you can see, it's showing the result data set size is not function. So in this time we are also yet had another thing. Suppose I simply remove this first or commenting and then click to the one. I want to check how many images are available. We can get only for the one image. Okay, so we can get only for the one image, and this image for the whole, cover the whole world or global data set we can get in here. Okay, only for the 1 year. Okay, so you can see between this time period, year of 2020 to 2021. So mainly it covered the year of 2020. Okay, so in this time I just simply check the time period. I can get only for the one images. So from this one images I can simply take the first image. So I use the first. So now it take the only for the first image, and this image I want to clip with my shapefile ROI. ROI is the Ukraine boundary. Okay, then click to the run. Then I can get the result. It's not right. I simply click to the run, and also you can see this data set has a band. Okay, you can see this has a only for the one band. This band name is the map. Okay, this band name is the map, and map. This under this band we can also get the some value such as the different types of land cover classes we can get under this band. Okay, so you can see tree cover, this value is the 10, shrubland, this value is the 20, then grassland 30, and we can get all of the classified classes value also in here. Okay, and also provide the color. You can see a specific color is provided. Okay, so in this time I just simply add this band in here. I just simply yes, I simply visualize this band, map band. Okay, so now this map band is visualized and I can get this result in here for the Ukraine. So here I can get all of the classes, which class is available. So in this time, suppose in this time I want to separate. Suppose in this time I want to separate only for the build up area. Suppose from this Ukraine region, I want to need only for the build up area region or build up area I want to need. So for that, I just simply take a variable. Suppose this variable name is the suppose build up, and then I simply call this data set and paste here. And in this time, I simply use the equal sign. Equal, I simply put the build up value. I can get the value from here. You can see build up. Build up value is the 50. Okay, just I simply copy the value of the 50 and then simply paste in my code. Okay, and now I want to show the result. So I simply use the map dot add layer again. In this time, this map is showing only for the build up area. So just I simply call the build up and paste here. I want to show the result look like way. Suppose mean is 0 and max suppose 1, and use the plated. Such as I simply add here the suppose gray color, and also is here the build up red color. So in this time you can see it also added the another layer, and this layer is only showing for build up region of Ukraine. Okay, so I simply zoom in. So these are full classified images, and also you can see now the red pixel value it's identify only for the build up region. You can say I can get the build up where the build up is available. I can get only for the build up. Okay, so it also say that it is the build up area map. Okay. Suppose you want to show the another class. Suppose I simply go to the value. Suppose I want to show the all of the cropland in Ukraine. Okay, all of the cropland I want to display. Just I simply put the value for 40. This is the value of the cropland, and then I simply paste in my corridor. So I simply paste in here, and then I want to show, suppose cropland, I want to show the cropland as a yellow color. You can use any color for showing this result. So in this time when I click to the run, in this time you can see I can get the another layer map in here, and now it's showing only for the cropland map of Ukraine. So it loaded. Yes. So now you can see I can get the cropland map of Ukraine. So this is the cropland map. We can get only for the cropland in here. So in this time, suppose you want to calculate it, how much cropland is available in this whole country. You want to calculate this area. Okay. So for that we can also use here the variable is doesn't matter. You can use any variable name. Okay. So you can use here the build-up area, but I can get the result for cropland. It doesn't matter. Variable name can be anything. Okay. In this time, I want to check how many area is available for the build-up or cropland. Okay, so I just simply use here this same name, then it's so better for understand. Suppose I simply put the variable suppose cropland. Okay, and I store the in here the cropland value 40, and then paste here this cropland in here, and click to the run. We can get the same result where the land is available. We can get the value is the yellow color in here. So you can see. So in this time, I want to calculate it. How many cropland is available for this region? Okay. So for that, I just simply take a variable. Suppose this variable name is that area image. You can use any variable name. I can put the variable name is the area image, and then I just simply call the cropland. This variable I called because this variable is stored all of the cropland area. Okay, I simply paste in here cropland, and then in this time I just multiply. With a function. Mainly this function called the image.pixel area. Okay, this function calculated the area of the pixel area. So basically in this time we can get only for the pixel. Okay, all of the things will be pixel. So mainly this function is calculated the area as a pixel in a square meter. We can get the result in a square meter.
Okay, great.
Square meter. Suppose I want to get the result square meter. So for that, in this time I simply take a variable. Suppose I put the variable name is the area. Okay. Then simply call the area image. And then mainly when you want to calculate the any area or calculate anything for any specific region, it can be total area, it can be average, it can be any value. When you want to calculate it, we use a function. This function called the reduce region. Okay, this is a function. This is a reduced region we can use when you want to calculate the any value. It can be total, it can be average, it can be maximum, it can be minimum. We can use it. Okay. Now you can see I just simply use a reduce region and then click to the run. So here I can get all of the argument. I simply put all of the argument step by step. So I make a dictionary in here and then also put here the another curly bracket in here. And then first of all you can see reducer. So first of all reducer is a statistical function. In this term you can see I want to calculate the total area. Okay, for that I simply use the reducer dot sum. So sum it calculated the total. Okay, and then geometry is your area. So my area is that ROI, sorry, lowercase RY. Then scale is the sentinel. I can simply use the 10-meter resolution in this time. And then CRS not need. I simply remove. Max pixel is need because it's a big region. So just I simply put the max pixel such as the highest value is that 1E13. Okay, then it's remove it not for this time. In this time, when I want to print this, I simply print this result from here. Simply call the area and paste in here and click the run. So now you can see I can get the result how much a square kilometer of the cropland is available for the Ukraine. We can get the result in here. We're calculating this area. So it computation. So this is a big region, so that's why it takes some time for calculating all of the pixel value area. Okay, so we can wait some.
And we can do this function for any region, one region, yeah?
Yeah, any region you can use it. Just you can simply change the area and then you can easily get this result. Okay? For the any region we can use.
We can use this map, this product, for validation our data.
Yeah, we can also use this. Yeah, we can also use this for the validation data set. Suppose you want to make the land use land cover classification map for the any other satellite image such as Lancer or Sentinel you can use. Then you can easily use this data set for check the validation and also get the accuracy. Okay? We can also use it for validation.
And Sentinel-1, it's available free or no?
It's also available for free. We can use the Sentinel-1 image collection is also free in Google Earth Engine platform. Okay, so this is Sentinel-1 SAR dataset. We can also use the dataset freely from here and use it. So all of the band, all of the things we can get the ACS polarization, dual band post polarization, single co-polarization, dual band, all of the band we can easily get in here and use it for the different purpose.
We can use that Sentinel-1 for land use, land cover?
Yeah, we can also use it. Yeah, we can also use it for the making the land use land cover classification. So it also working for calculating the area for the all of the propellant.
There is only one like this product. Only one?
In this
Or
time, yeah.
yeah.
So in this time, for we can also use that another product. It also provided the MODIS satellite images. Okay. So MODIS satellite image. It's also provided the land use land cover data set, yearly data set. It also provide. We can also use. We can see.
But resolution is bigger.
Yeah. 500-meter resolution. Or
this product that you show me, the most detail, only 10 meters, yeah? And for Ukraine also, there are, yeah, for Ukraine. For whole world. Oh, okay, great. Mhm. Oh, okay. It, yeah, very real time. And the and the same process like you show me. Oh, okay. What is mean scale? Oh. Mhm. So so 1 pixel is 1,000 meter now. Oh. Uh-huh. Mhm. Uh-huh. Okay. Not much. Mhm. Uh-huh. Mhm. Okay. 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 I- uh, ah, a sum, it's a square. Square. Sum. A sum, it's another value. It's a square. Yeah. Yeah. It's a square. Oh, okay. Mhm. 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 Nested list. Mhm. 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 Yeah. Mhm. Yeah. Mhm. Mhm. Okay. A lot of information, new.